Good morning, friends. Today I am going to explain the most important topic of mechanics, that is the law of conservation of angular momentum. Generally, the question will be appearing here like this: state and prove the law of conservation of angular momentum. Before going to talk about this theorem or statement, first of all, we should know what is momentum and what is angular momentum. So, in your previous classes, you have studied about that momentum is nothing but it's a product of mass and velocity, or linear momentum is nothing but it's a product of MIVI, or simply it's a momentum, or linear momentum is a product of mass and velocity. So what about angular momentum? Here a little bit introduction of this angular momentum I have given here. What is angular momentum? For that purpose, let us consider a particle P having a some mass m, which is rotating around a fixed position, having a position vector r with respect to the origin O of inertial frame of reference as shown in the figure. So what is inertial frame? Means in which Newton's laws are holds good. So a particle P is moving with a moving around a fixed axis, having a some mass and having a some distance or position vector with respect to the origin. Okay, so that time the linear momentum of the particle can be given as P is equal to mv, or mv is equal to p, be the linear momentum of the particle in this particular inertial frame. The angular momentum I of the particle about O is defined as the product of or the vector product of r and p. So vector product of r and p is that can be written as I is equal to r cross p. So here this the direction of I is perpendicular to the plane containing r and p. Here it means the angular momentum definition is what? That is I is equal to r cross p. So like this, linear momentum is what? It's a product of mass and velocity. The angular momentum is the product of, or cross product, or vector product of r and p, this one. Okay, so this p is nothing but this is linear momentum. Here this is the definition for the angular momentum. Now let us consider a number of particles are there. If we consider a system is having a n particles, then that time the angular momentum of the system about origin O is can be defined as here. So if the number of particles are there, means here I can write summation I is equal to 1 to n I is equal to summation of I is equal to 1 to n I is nothing but a r cross p. So ri pi. So this equation we are going to utilize in this particular state theorem. Here the angular momentum is the product of position vector and a linear momentum. You remember this point. Next, come to the point, that is what is the law of conservation of momentum. So law of conservation of momentum says this: if no external torque, if there is no external force or external torque acts on a body which is rotating about a fixed point, the angular momentum of the body is remains constant. When the body is moving in the linear position, then we are calling simply a force. Or when the body is moving in a rotating around a fixed position, so that time we are introducing a new term, that is called the torque. Okay, so what is torque? Torque is nothing but a moment of a force. It's just like a force only, but we have to introduce this torque when the body is rotating. Okay, so moment of a force, or the product of a force and its perpendicular distance from a point about which it causes a rotation. For example, that is opening a bottle cap or opening a door. So where we have to apply some force on a perpendicular distance. So that can be written as torque is equal to r cross f, or a vector product of position vector and a simple linear force are just like a force only. Okay, next come to the point. Here the statement is: if no external torque acts on a body rotating about a fixed point, the angular momentum of the body remains constant. We have to prove this one. So when there is no external torque, or external torque is equal to the 0, then the angular momentum is, just now I told you, Ri cross Pi is, this remains constant. We have to prove. To prove that one, we have to consider some external forces is acting on the particle. First of all, we have to take the situation where here in the statement is calling, the statement will be, if no external force is acts on the body. Okay, now we have to take to reverse of this statement, that is, when some external forces are acts on a particle, they exerts a torque on them. So when external force are acting, exerts some torque. So now the angular momentum of the particle with time, the rate of change of angular momentum is given by. So this is the definition for the angular momentum. It's a vector product of position vector and linear momentum. Now this is the first equation, let us suppose. Now the change in angular momentum, some when you apply the force, then due to which some angular momentum is also changes. Okay, so when you apply the torque or some force, so due to which this angular momentum is changes, so that change is represented by a dl by dt, change in angular momentum with respect to time, dl by dt, where I is equal to 1 to n and d by dt of ri cross pi we can write. Now here we are using this d by dt u ri into pi. This is just like here I have given two notes. So this note is for this one, that is ri pi is just like a uv. So we know the differentiation of uv, uv formula is du by dt cross v plus u into dv by dt. So like this, in this formula we have to write this one. Then we will get dri by dt into pi plus ri into dpi by dt. Now next, this total terms is equal to the 0. How it is equal to the 0? This is I have given here note 2. That is, we know that differentiation of position vector is velocity. Okay, dri by dt is nothing but a vi. So we got this position will be vi into pi. Okay, vi into pi. We know that vi is equal to this one is pi. Pi is equal to the m into vi. So at this position we can write m into vi. So I can write here vi into mi into vi. So this is equal to mi, and I take out the mi, vi into vi. We know that vi into vi is equal to the 0, because here if you take the cross product of this one, I, j, k, vx, vy, vz, vx, vy, vy, vz. So if you take the determinant of this one, then we will get 0. So this total term will be equal to the 0. So that's why here this total term dri by dt into pi is equal to the 0. Okay, now the remaining term is what? Ri into dpi by dt we get. So here I can write dl by dt is equal to summation of I is equal to 1 to n ri into dpi by dt. Next, ri, we know this term I can write in the form of ri into, so we know that dpi by dt is nothing but a, according to the Newton's second law, force is equal to the rate of change of momentum. Here F is equal to dp by dt, or you can write ma also. Okay, so the rate of change of momentum, or it's a product of mass and acceleration. So by the second law I can write dl by dt is equal to I is equal to 1 to n ri, and this term can be written as fi. So just now I told you what is torque. Torque is nothing but it's a product of position, it's a product of r and f. So here ri and fi we got. So we can write I is equal to 1 to n. This will be equal to the tau I, or you can write this is tau external force. Okay, let us take this is equation number 1. Now what is our statement? This external torque is equal to the 0. So that time dl by dt will be remains constant. Okay, here that is L is remains constant. If no external torque is acts on a body, then that time here the angular momentum of the body remains constant. So that's why Here when external torque is 0, here I wrote weight tau external is nothing but a sum of external torques acting on the system. If tau external is equal to the 0, so that time then dl by dt is equal to the 0. Here dl, if this is equal to the 0, this equal to the 0, then dl by dt, this total term equal to the 0. When this differentiation of something 0 will be happen when this must be constant. When this term must be constant means L is constant. What is L? L is nothing but a angular momentum. So this shows that in rotatory motion, if no external torques acting on a system of particles, the angular momentum remains constant. This is the law of conservation of angular momentum. Thank you. For more videos, subscribe my channel Physics.